Welcome to AI Podcast. I'm Daniel. Today we're unpacking an ACL 2025 paper titled Contextual Experience Replay for Self-Improvement of Language Agents. The short version is this. The authors propose a training-free way for language model agents to learn from their own past trajectories during inference. By replaying distilled experiences in the prompt, agents get noticeably better on realistic web tasks with modest extra token cost.
I'm Maya. That sounds practical. Who led the work?
It's led by Yitao Liu, with colleagues from Princeton University, the University of Hong Kong, and Stanford University. Their goal is to help agents stop starting from scratch every time they face a new task on the web.
Right. That cold start feeling is real. What problem are they targeting exactly?
In realistic browsers, even strong models struggle with multi-step goals because they don't accumulate environment-specific know-how. Humans remember page layouts, helpful URLs, and common routines. Most agents don't. So the gap is simple. Keep the model the same, but let the agent carry forward useful experience from previous tasks.
Okay, so how does their method actually work?
They call it Contextual Experience Replay, or CER. After a task, the agent distills the trajectory into two compact pieces. First, dynamics, which summarize important page types or locations, often with handy URLs. Second, skills, which are reusable step-by-step action patterns, like how to post on a forum or manage an order. These go into a small, growing buffer. On the next task, the agent retrieves a handful of relevant dynamics and skills, converts them into natural language hints, and inserts them into the prompt before acting.
So it's like giving yourself crib notes based on what actually worked last time. And it's training free, which is nice.
Exactly. CER supports three modes: online learning after each task, offline learning from a small set of pre-collected trajectories, and a hybrid that does both. The core agent is unchanged. CER just shapes the context the agent sees.
How did they evaluate it?
They used Web Arena and Visual Web Arena, two realistic web navigation benchmarks. The base agent uses GPT-4 inside a browser environment called Browser Gym. For the visual benchmark, they also apply set of marks to label clickable elements on screenshots so the agent can refer to them precisely. Retrieval is intentionally light, typically a few dynamics and a few skills, so prompts stay compact.
Where did the offline data come from?
For Web Arena's offline setup, they asked unfamiliar users to explore the sites for about 3 hours, design representative tasks, and then human-annotated the resulting gold trajectories. They also experimented with using an LLM explorer to generate similar data. The idea is to seed the buffer with clean, goal-oriented examples.
All right, results. How much does CER help?
On Web Arena, the hybrid setting reaches an average success rate of 36.7% and delivers roughly a 50% relative gain over a comparable GPT-4o baseline. On Visual Web Arena, CER achieves 31.9% and outperforms a tree search method while using far fewer tokens. They also cap each task at around 30 steps, which helps keep costs predictable.
Nice. Are they just memorizing whole solutions?
The evidence suggests not. They check cross-template performance and see improvements, which indicates the agent is learning reusable patterns rather than copying entire trajectories. CER also balances stability and plasticity. It largely preserves baseline skills while adding new ones.
Does it work with open source models too?
Yes, though the gains are smaller. With an open model like Llama 3.170b, CER still helps over a React-style baseline on a large Web Arena split. The authors note weaker models can be less reliable at formatting actions and distilling multi-step skills, which likely limits the lift.
Any caveats we should keep in mind?
A few. The main results use a proprietary model, so exact reproduction can drift as APIs change. The quality of the offline seeds matters. Cleaner trajectories lead to better experiences. Retrieval policies are kept simple here, so sensitivity to buffer size or selection criteria deserves deeper study. And some of CER's advantage on the web comes from leveraging URLs and page types, which may not transfer directly to other domains without adaptation.
If I'm building a web agent today, what's the low-effort way to try this?
Start small. After each task, summarize 1 or 2 page types you visited and a couple of clean general skills you used. Save those as short patterns. On the next task, retrieve a handful that match the goal and site description and prepend them to the system prompt. Prune anything that proves distracting. If you already use sampling or light search, keep it. CER tends to complement those methods.
And for research directions?
Automate experience curation so useful items rise to the top. Learn adaptive retrieval policies instead of fixed numbers. Broaden to desktop or API orchestration tasks. Expand open model evaluations for reproducibility. And add safety checks that catch stale or misleading experiences before they affect actions.
Great. Quick recap. Training free experience replay inside the prompt. Solid gains on Web Arena and Visual Web Arena, and a practical path to make agents feel less cold from one task to the next. If you want the details, look up Contextual Experience Replay for self-improvement of language agents in the ACL anthology.
That's it for today's AI podcast. I'm Daniel with Maya. Thanks for listening, and we'll see you next time.